One of the top utilities provided by GPU.net is GPU accelerated computing. This utility leverages the power of graphics processing units, or GPUs, to accelerate computations, making it highly beneficial for tasks that require heavy processing power, such as machine learning, deep learning, and scientific simulations. By offloading intensive tasks from the CPU to the GPU accelerated computing significantly reduces processing time, enabling faster data analysis, simulations, and model training. This utility is particularly useful for workers with large data sets and complex algorithms, improving both performance and efficiency in computational tasks. Let's dive a bit deeper into GPU accelerated computing and how it works within the context of GPU.net. So what is GPU accelerated computing? At its core, GPU accelerated computing involves utilizing a graphics processing unit, or GPU, to perform computational tasks that will traditionally be handled by a central processing unit, or CPU. Now, GPUs are designed to handle parallel processing tasks that can be split into smaller chunks and processed simultaneously. This makes GPUs particularly well suited for tasks that require large-scale mathematical computations like simulations, data analysis, and machine learning. Why use GPUs for computing? While CPUs are optimized for sequential tasks, basically one instruction at a time, GPUs excel at processing multiple operations in parallel. For instance, a CPU might have 16 cores that handle tasks under one or another, while a GPU can have thousands of smaller cores working in parallel. This makes GPUs ideal for workloads that need to process large amounts of data simultaneously, such as matrix operations in machine learning and deep learning models, image and video processing, which require massive amounts of pixel-level calculations, and scientific simulations, where many variables need to be calculated at once. How GPU.net leverages GPU accelerated computing. GPU.net is a platform that provides tools and utilities to help developers harness the power of GPUs for accelerated computing. It enables the development of applications that offload specific computational tasks to GPUs, making them run faster and more efficiently. So here's a few areas specifically where it helps. So machine learning and deep learning. Training machine learning models, especially deep neural networks, involves repetitive matrix multiplications and large-scale linear algebra operations. These tasks are computationally expensive and can take a long time to run on a CPU. GPU accelerated dramatically speeds up these tasks by processing multiple operations in parallel. Tools like CUDA, or Compute Unified Device Architecture from NVIDIA, allows developers to write programs that take advantage of the GPU acceleration, reducing training time from hours or days to minutes or hours. Scientific simulations. So simulations in the field like physics, chemistry, and biology often require calculations involving large data sets. For example, simulating molecular dynamics or fluid dynamics involves calculating millions of interactions simultaneously. GPUs can process these in parallel, dramatically reducing simulation time. GPU.net also provides support for integrating GPU-accelerated libraries, such as those used in computational fluid dynamics, or CFDs, molecular modeling, or weather prediction, which could otherwise take a long time to compute using a CPU. Data analysis and big data. Analyzing large data sets is another area where GPUs shine. Data science and big data tasks often involve operations like matrix factorizations, sorting, or even processing of high-dimensional data in machine learning models. These operations are highly parallelizable and benefit immensely from the GPU acceleration. GPU.net also allows you to integrate GPU acceleration into data processing frameworks, helping you analyze large data sets faster and making real-time decisions more effectively. And lastly, graphics and visualization. GPUs are traditionally used for rendering graphics, but GPU accelerated computing extends this power into non-graphics tasks as well. For instance, applications that require complex visualizations such as 3D rendering or scientific visualizations or high-performance gaming engines can use GPU acceleration to handle rendering and computation simultaneously. GPU.net also offers APIs and libraries to help integrate GPU-based rendering and processing seamlessly into visual applications. What are exactly the benefits of GPU-accelerated computing? So there are 4 different things that you should know. Speed, which will be the most noticeable advantage, and with tasks that once took hours can be completed in minutes or seconds, as GPUs can handle multiple computations simultaneously. You have efficiency. By offloading heavy workloads from CPUs, the GPU acceleration reduces the computational load on the central processing unit, freeing up the CPU to handle other tasks. Scalability. GPUs can be scaled up, allowing for even more computational power by using multiple GPUs in parallel. And also it's cost effective. While GPUs may have higher upfront costs than CPUs, they can deliver greater performance for specific workloads, making them cost effective in the long run by reducing time spent on processing tasks. In conclusion, GPU accelerated computing within the GPU.net network empowers users to significantly enhance their performance of their computational tasks by leveraging the parallel processing power of GPUs. Whether you're involved in machine learning, scientific simulations, or data analysis, or complex graphics rendering, GPU accelerated computing can speed up your workflows, save you time, and enable you to solve problems that were previously too resource intensive to tackle on traditional CPUs. This is a powerful utility that is becoming increasingly essential in fields requiring intensive computational and real-time processing, offering a distinct edge in performance and efficiency. Go invest in GPU.net now.